We know that you can't exercise as hard or as long when you are hot compared to when you are at normal temperatures. But what about when you are cold and your body temperature has dropped? In today's episode, we'll take a look at what happens in a cold weather situation where your body temperature has fallen. Can you exercise as hard and for as long? And if there is an impairment, what might be happening in your body to cause it? As we saw in the Tokyo Olympics in summer 2021, hot weather can be an extreme environmental challenge for athletes. Understanding the degree of impairment and also the physiological reasons causing this has been a major theme of research in exercise science over the past half-century and longer. Surprisingly though, despite the presence of cold weather over much of the world, far less research has systematically explored the impact of cold weather and low body temperature on physical performance. Such questions are relevant not just to winter athletes or polar expeditions, but also critical to search and rescue teams looking for lost hikers and skiers. And if there is an impairment, it is not clear whether it's because of the low body temperature by itself, changes to the muscle, or the lower amount of oxygen reaching the muscles due to blood vessels constricting to reduce heat loss. In 2018, our lab decided to test this question. We first either kept trained cyclists at a normal temperature in a 23 degree Celsius chamber, or else dropped their body temperature by half a degree Celsius in a 0 degree Celsius chamber. They then rode a stationary bike for 15 kilometers as fast as possible. In both of these conditions, they breathed normal room air, which has 21% oxygen. We also had a cold plus hyperoxia trial where they were cooled by half a degree Celsius and then did the cold 15 kilometer time trial while breathing higher than normal oxygen at 40%. The idea here is to test whether any drop in performance in the cold was because of less oxygen going to the muscles. Namely, here, the cyclists would still be cold and have less blood flowing to their muscles, but that blood would have more oxygen than normal. And if so, then performance might be as good as when they are at normal temperatures. What did we find? It wasn't comfortable, but our cyclists cooled by half a degree Celsius over 50 to 100 minutes. We saw that the 15 kilometer time trial, with all the heat being produced during exercise, increased body temperature about 1 degree Celsius, and this was the same in all three conditions. The increased oxygen during the cold plus hyperoxia trial had no thermal benefits to either core or skin temperature, with this graph showing that core temperature was about the same for both cold and cold plus hyperoxia, each about half a degree lower than the neutral trial. However, the hyperoxia trial did maintain higher oxygen levels in the blood, measured with a finger pulse oximeter, than either the neutral or cold trials. What about actual performance? In the 15 kilometer time trial, the cold condition of being in 0 degrees Celsius and cooled by half a degree made our cyclists much slower at every point in the test, by about 15 watts compared to neutral, which meant about 20 seconds slower overall. However, while they were just as cold, the greater oxygen availability when breathing 40% oxygen allowed the cyclists to ride as hard and as fast as if their body temperatures were normal. So overall, this study clearly shows that exercise performance does become impaired when our body temperature drops below normal. This is important for athletes to make sure they avoid getting cold while competing in winter sports. For search and rescue, this gives insight about how hard accident survivors might be able to work to rescue themselves. In exploring why this might be, we suggest that it's not because the muscles themselves cannot work as well, but that they aren't getting enough oxygen because of reduced blood flow. Hopefully studies like this will spur much more research into the impact of cold on human physiology. I'm Professor Stephen Cheung, and I run the Environmental Ergonomics Lab in the Department of Kinesiology at Brock University in Canada. We post new videos on different topics in environmental physiology every Wednesday. Thanks for watching. We'll see you next time.